Today is May 29th, 2018, and this is my second attempt to record today. Wanted to review some of the things about the second fundamental form. The second fundamental form had an L and an M and an N, and the second fundamental form was after a transition. I think, did I have a way of directly calculating L, M, and N? It seems like I did. I was working on some notations, kind of talking about a UV parametrization, defining a vector R being u comma v comma z of u comma v, where z is the elevation above the UV non-tangent plane, because UV variables were generally considered to be non-tangent. Noted that del R del U was 1, 0, del Z del U. Del R del V is 0, 1, del Z del V, based on, and del R del Z is 0, 0, 1. And then thinking further about that, there were two ways of writing the Gauss normal map. The normal map can be expressed as a cross product of del R del U cross del R del V, and divided by the norm of del R del U cross del R del V. But when that is calculated, the cross product comes out to be PQ negative 1. And it should be noted here that while Z is f of u comma v, the surface, it's not the same as f, which is f of u comma v minus z, but their partial derivatives with respect to u and v are equal. So that means that del z del u is the same as del f del u, and del z del v is the same as del f del v. And whereas del f del z, or del z del z would just be 1, del f del z is negative 1. So it seems like I saw something that gave the values of L, M, and N directly this morning. Now, what was that? I kind of got focused on some other things this morning while I was working on it, like that this usual form, it kind of formalizes the requirement that du and dv should be small, but it kind of makes ambiguous the requirement that the approximation is only valid close to the origin. I think what we're missing here is the dx squared plus dy squared form. Here is what we need. Putting a dx dy and dx dy in there, that makes it a little clearer that we are converting from the coordinate system where, damn it, I wish I hadn't lost that video this morning. Because I don't think this is right. I put a question mark there, but because I'm thinking of two different sets of variables. In the UV sets of variables, the UV plane is not necessarily tangent to the surface f of u comma v at the origin. On the other hand, with the xy variables, the xy plane is tangent to the surface f of x comma y, and with the long and short curvature aligned with the x and y directions. So in the UV direction, you might have zeroth and first order terms, and the xy plane only has second and higher. So the question is, did I screw this up and put the L du squared plus 2m du dv plus n dv squared, or did Wikipedia screw it up? Because probably Wikipedia did. Just because Wikipedia is by a number of authors, and it's quite likely that one author was using u comma v um, as the natural coordinate systems, or as the tangential at the origin coordinate system, um, and another author may have been using x comma y as the tangential at the coordinate system. It's pretty much arbitrary which one you use when. Yeah, whoever put this in classical notation here stuck those du's, du, dv, and dv squared in there. And I think that's backwards because up here it has z equals L x squared over 2, or L dx squared plus 2m dx dy plus n dy squared. So they're confusing the variables for some reason. But it was, I would say, screwed up by Wikipedia. Definitely. Now, if I could only think clearly enough to fix it, then we'd have, this was what we had for r sub uu, r sub uv, r sub vv.